So we're going to look at some of the common angles that we're going to use or that are normally used in trigonometry, and then we're going to look at what their values for these trigonometric functions are. All right, so pay attention. This looks like it might be a lot of value, but it actually isn't that much. Okay, so the first thing I'm going to go do here is I'm going to write down the angle theta, and I'm going to write down this angle in both radians and degrees. Okay, so our theta values, we'll start with 0. So we have 0 degrees, well, that's also 0 radians. Okay, then I have 30 degrees, which turns out to be pi over 6 radians. Okay, then I have 45 degrees, and that turns out to pi over 4 radians. 60 degrees, make that pi over 3 radians. 90 degrees, and that's going to be pi over 2 radian. And then finally we have 180 degrees, and that's going to be pi radians. Okay, so first thing I'm going to do here is I'm going to go ahead and write down the terminal point. Okay. So my terminal point for 0, 0, now let's think about it. Let's say this is my unit circle. Okay. If my angle is 0 degree, that means my initial and my terminal side are on the same spot, which means this is going to be a point 1, 0. So my terminal point here is 1, 0. So for pi over 6 or 30 degrees, my terminal point comes out to root 3 over 2, comma 1/2. For 45 degrees, it comes out to root 2 over 2, comma root 2 over 2. And then for 60 degrees, it comes out to 1/2, comma root 3 over 2. And then for 90 degrees, right, 90 degrees is this point over here, which comes out to 0, comma 1. And finally, pi, an angle of pi, if you remember, was 180 degrees. So this is my terminal side, and that point is -1, 0. Okay, so let's look at our trig functions here. We're basically going to look at sine theta, cosine theta, tan theta, okay, we have cosecant theta, secant theta, and cotangent theta. Right, what you want to really pay attention is sine. If you know sine theta, basically we can derive everything from sine theta. Okay, so sine theta is your y coordinate. So sine of 0 is 0. Again, it's your y coordinate. The sine of 30 degrees is 1/2. Sine of 45 degrees is square root 2 over 2. This is square root 3 over 2, 1, and for 180 degrees, it's going to be 0 again. Okay, now really look at this. Think about from 0 to 90 degrees, you have 0 and 1, and then everything in between. Now you can think of these numbers here as, you can learn them the following way. It's 1, square root of 1, square root of 2, square root of 3, and then all divide by 2. Well, how do I get cosine theta? I can look at my points here, and I can figure out what the x coordinates are, and that's going to be my cosine theta. So cosine theta is going to be 1, root 3 over 2, root 2 over 2, 1/2, 0, and -1. So again, let's see. If you leave out pi for now, cosine theta is exactly sine theta written in reverse order, right? If you write sine theta in reverse order, you get cosine theta. How do I get tan theta? If you guys remember, tan theta was nothing but sine divided by cosine. So I'm going to do 0 divided by 1, which is 0. And then I have 1/2 divided by root 3 over 2, and I get that to be 1 over root 3, or you can also write this as root 3 over 3. I'm dividing the same number, so I get 1. Root 3 over 2 divided by a half gives me root 3. And then 1 divided by 0, it's undefined. And 0 divided by negative 1 is 0. Okay? So remember one thing, tangent of 90 degrees is actually undefined. Cosecant theta. How do we get cosecant theta? We divide sine theta by 1, right? So sorry, divide 1 by sine theta. So I get 1 over 0. So that's going to be undefined. Okay. And then this is going to be 2. This is going to be 2 over root 2, or simply put, root 2. This is going to be 2 over root 3, or I can look at it as 2 root 3 over 3. And this is going to be 1, and this is going to be undefined again. Okay? Secant theta. Secant theta is 1 over cosine theta, so 1 divided by 1 is 1. This is going to be 2 over root 3, or 2 root 3 over 3. Okay. This is root 2. This is going to be 2. And this is going to be 1 over 0, which is undefined. Okay. And then secant of pi is going to be negative 1 again. Okay. And then finally, cotangent of theta is 1 over tangent theta. So 1 over 0, this would be undefined. Okay. This one is going to be root 3. This one's going to be 1. This one's going to be 1 over root 3, or root 3 times 3 over 3. Again, tangent is undefined, but it's undefined, but if you think about what is tangent, right? Tangent is sine over cosine, and we know cotangent is cosine over sine, so that becomes 0 or 1, which is 0. And finally, here, cotangent is going to be 1 over tangent, which is 1 over 0, and that is undefined. Okay? So this is your table for the most common functions and their trigonometric values. Right? This would be something that you will need to memorize, unfortunately. Again, they look like there are a lot of values, but if you know the relationship between your functions, you really only need to know the values for sine, and you can figure out the rest of the table for yourself. So we looked at the basic or the common angles that we use, and we looked at the values of trigonometric functions for those. What we're going to do now is take a small example and see what if I had a different angle that was not one of the common values, right? How could I find trigonometric functions using symmetry? So think about your angle 5 pi over 6, okay? If you think about 5 pi over 6, that angle is between pi over 2 and pi, which puts it in the second quadrant, right? Because I'm opening my angle counterclockwise. So your angle 5 pi over 6 is roughly going to be about here, right? So this is your angle 5 pi over 6, okay? And so once I have my unit circle here, okay, what I want to do is I want to figure out what the trig functions for that angle are. Well, now if you notice, this angle is actually a reflection of the angle pi over 6, right? So if I take pi over 6, my terminal point, this is my terminal point P, and this point here is actually a reflection of that, right? So I'm going to call that P prime. So if you look at your previous table, what are my coordinates for P here? For pi over 6, I'm going to get root 3 over 2, comma 1 over 2. Okay, so since this is a reflection about the y-axis, what changes? The only thing that changes is my x is positive here, my x is going to be negative here. So it's going to be negative root 3 over 2, comma 1 over 2. Well, and so my trig functions now, my sine theta, or sine of 5 pi over 6, is going to be the y-coordinate, which is a half. Okay. My cosine theta, or cosine of 5 pi over 6, is going to be the x-coordinate, which is negative root 3 over 2. All right. Then tangent of 5 pi over 6 is going to be the division of these two. It's sine over cosine, so that's going to be negative 1 over root 3, or you could also write that as negative root 3 over 3. Okay, let's look at cosecant. And cosecant of 5 pi over 6 is going to be 1 over that, which is 2. Secant of 5 pi over 6 is going to be negative 2 over root 3, or if you want to write that as negative 2 root 3 over 2. And finally, cotangent of 5 pi over 6 is given by negative root 3. Okay, so we can use symmetry and one of our common angles to figure out what the trig values for 5 pi over 6 is going to be.